Hi everyone. I want to make sure that we give some attention to interpretations with the second derivative. We know how, hopefully, to interpret first derivatives, know what they tell us. We need to think about what second derivatives are telling us in the context of a word problem other than acceleration. Okay, so we have some function, d equals f of w, which outputs the dose, so that's our d, of a painkiller as a function of the weight of the patient. So here d is dose. Let me make sure I'm not off the screen. No, I think I'm good. In milligrams. And w is weight in pounds. Okay, we know that f of 140 equals 120 and f prime of 140 equals 3. So I don't ask for it, but I'd actually like to make sure we're clear on what those statements mean. So we're thinking about a function that inputs weight and outputs dose. Okay, so if we know that f of 140 equals 120, that means we go through the point 140, 120. Or we could say that a patient whose weight is 140 pounds should get a dose of 120 milligrams of painkiller. F prime of 140 equals 3 means that if we were to draw our tangent line, it would have a slope of 3, which, if we make it 3 over 1, is saying that if the patient's weight increases by 1 pound, the dose should increase by about 3 milligrams. And this is for patients in the ballpark of that 140-pound weight. Okay, so now we have a second derivative statement. F double prime of 140 is equal to negative 1/2. So the units on this, here we had slope. Right here, we'll put it. If we can squeeze all sorts of things in here. This was milligrams per pound. And if we take a second derivative, we know the units are going to be milligrams per pound, which you could rewrite as milligrams per pound squared. That's a legitimate way to write it, but I'm actually going to leave it this way for the purposes of interpretation. So what we said for f prime was the gist of it was that if the weight increased from 140 to 141, we'd predict the dose increase to be 3 milligrams. And what this is saying is if the weight increases from 140 to 141, we would expect the rate at which the dose is changing to drop by 0.5. So this is negative 0.5 milligrams per pound. So this is a 1 pound increase. So this is where I'm getting the from 140 to 141 pounds. And what's changing is f prime. F prime was 3 milligrams per pound. So basically, if we go from 100 to 141 pounds, we expect the dose to increase by about 3. But if we go from 141 to 142, it's not supposed to increase by as much. I'd really only expect it to increase by about 2.5. So the rate at which the dose is increasing is actually slowing down. Instead of increasing by 3 milligrams per pound, that should drop to around 2.5 milligrams per pound. Okay, so there's lots of rambling. Let me see if I can say it once more in a nice way. So if f double prime of 140 equals negative 1/2, that means the rate at which the dose is increasing per pound of weight should drop by about 0.5 milligram per pound if the person's weight increases from 140 to 141. So based on all of those different things we just said, we should be able to make some estimates, and actually the picture is kind of starting to get us in that direction. We should be able to estimate the dose at 139 or 142 pounds. So what we've got here is we know what the tangent line looks like, and we know the function is concave down. So if we try to estimate f of 139, The F prime is telling me that increasing your weight by 1 pound should increase your dose by about 3 pounds, and that should work in the other direction. So I would say your dose should drop by about 3 milligrams. And what were we at? 120. So it would be in the ballpark of 117. But I can actually fine tune maybe even a little more than that because I know it is concave down. So I know that's a little bit of an overestimate. So maybe I think it's more like 116 or something along those lines. So I think it should be less than 117 pounds for sure. Or I'm sorry, milligrams. Let me remember what my thing is. So my tangent line would predict 117 milligrams, concave down, so it's probably a little less than that. It is a little less than that. For 100, here, we'll write this so that we're really answering the question. Maybe about 116 milligrams. Keep trying to write pounds on that thing. For the 142 pounds, if we use the tangent line, that's an increase of weight of 2 pounds. So our dose should increase to F of 142 should be in the ballpark of 126 milligrams according to the tangent line. But again, I have a little bit of extra information. I know the function is concave down. So really, even saying that 141 pounds should give us 123 milligrams is a little bit of an overestimate. And then from there, we only expect it to increase by another 2.5 pounds. So probably more like 124 or 125. So it's definitely smaller, a little bit smaller than 126. So we can say maybe that one is about 124 milligrams. 125, somewhere in there. Again, we're estimating and that's okay, but I do want you to recognize that 126 is definitely an overestimate. Tangent line is overestimating. All right, thanks for watching.